with Discovering Science, and this is my brother, Kevin Fogg.
Hi, everybody.
And first of all, we want to thank you again for purchasing one of our grab-and-go STEM packages.
And also staying safer at home.
So, this is our lesson number 3, which is Newton's Lab of Motion. And on the table in front of us, we have the 3 experiments that come in the Newton's Lab of Motion. And we want to go over a little bit about motion before we get into the stuff. So first, I have a question for you guys. And a question for you.
All
Am
right.
I standing still or am I moving around?
Well, right now you're moving.
Yeah, I'm definitely moving around. And a scientist would look at me when I'm moving around and say, oh, look, he's moving around. It doesn't really sound very scientific.
Yeah.
So somebody might say, oh, look, he's changing position. That sounds a little bit better, but I think there's a better term for it. In fact, when an object is moving around and changing position, scientists say that object is in motion. Why don't you guys do that with me? Get your fingers up like this. Fingers ready? If an object is moving around, it is in motion. One more time. In motion. But what if I just stand there and I don't move and I just stand perfectly still? Am I in motion? No. So a scientist is going to say, oh, look, he's just sitting there.
No,
I don't think so. No. Okay, a scientist might say, hey, look, he's not changing position anymore. No, probably not. In fact, if an object is just sitting there, scientists say it is... You're going to need fingers for this one. Scientists say that object is at rest. Say it with me.
At rest.
One more time, everybody. At rest. So an object that's moving is in motion, and an object that's just sitting there is at rest. So now the question is, if you have an object, like my rocket here, we'll use my rocket. If you have an object that is just sitting there, that object right now is, hold on, it is at rest. Now, if I wanted this object to be in motion, what can I do with this object?
Oh, you could ask it to move.
Move, rocket.
No, that's not
going to work. No. What can I do? Well, you know what? There's a lot of things we could do. We could kick it. We could push it. I could go, and it would probably blow right off the table. I could flick it. There are so many ways to make this rocket move. But what if I just told you there's actually only one way to make that rocket change position? What if I told you there's only one way to make that rocket go in motion? It would sound kind of silly, right?
Yeah.
But actually, that's the truth. I mentioned all these different things like flicking it and pushing it and even trying to blow it off the table. But the fact is, there's really only one way in the world of science, and that is a force. Oh. And in the world of science, a force, you put your hands up like this. In the world of science, a force is either a push or a pull. Everybody do it with me. A push or a pull. And if you think about it, all of those things that I mentioned were examples of a push or a pull. For example, I said to flick it. And if you look at a flick, it's simply a slow motion push of the rocket. Now, I also said I was going to blow it off the table, but the air will push the rocket. You know, even if I stand the rocket up and then lean it over, I just let go. I didn't push or pull, but the force of gravity pulled the rocket down. So there has to be a force. Something has to push or pull the rocket, or it's just going to sit there. In fact, that's Newton's first law of motion. Is that, and you guys can do this with me, you're going to need fingers for this. Newton's first law says that an object at rest will stay at rest until a force, let's do a push and a pull, acts on it. That means does something to it. So let's say it together. You ready? An object at rest will stay at rest until a force acts on it. Now, I have to say, I know I said that was Newton's first law, but the fact is Newton's first law has 2 parts.
Oh.
I know, but you already know the second part, and everybody already knows the second part. You just don't realize it yet. I'm going to say the second part, and I want you to listen to it, and you'll realize I know exactly the second part of Newton's law. It says, an object in motion will stay in motion until a force acts on it. It's the exact same thing as the first part.
Just
Only
motion.
we say in motion instead of at rest. So let's try that second part together. Here we go.
Okay.
An object in motion will stay in motion until a force acts on it. Very cool. That basically says if an object is moving, it's going to keep moving forever and ever until something stops it, until some force acts on it. And I'm going to demonstrate this. What I'm going to do is I'm going to take this and I'm going to throw it that way, and I'm going to put it in motion by using a force. And it's going to keep going forever and ever. And there's like another 50 feet over there. So it's going to keep going that 50 feet, and it's never going to stop ever until something pushes or pulls it. So here we go. Let's give it a shot.
Here we go. Maybe we can say force when you throw it.
Yeah, let's say force. Ready?
All right, here we go.
And force.
Force. Wait, I thought I was supposed to go further.
It was supposed to go forever and ever. I mean, Newton's first law says an object in motion will stay in motion until a force...
Wait a minute.
Gravity. Gravity pulled it down. That force acted on it. Plus, it slowed down right away because of air. The air was pushing on the rocket the moment I threw the rocket.
I thought the wall was going to stop it, but instead, the wall way down there, gravity came first. Yeah.
Now, here's a question. If we were to go to a place where there was no gravity and a place where there was no air, and we were to throw this, would it keep going forever?
I don't know. I think so.
Here's the funny thing. If we were to take this rocket into outer space, and I'm talking about far away from the sun, far away from the other planets, where the gravity is so minimal, and you were to launch this rocket or just throw it, or even just take it and spin it, and then you were to come back 1,000 years later, guess what? The rocket would still be spinning in the exact same spot because there wouldn't be a force to act on it. Science is pretty amazing. That's pretty interesting to think about. So I'm going to put this rocket back for now, and we're going to put Newton's first law together. We're going to say it together, the first part and the second part, all together.
Whoa.
You ready?
All right, let's
Here we
do
go.
it.
You're going to need fingers,
Shake
guys.
Here we go.
I'll try it again. Here we go. An object at rest will stay at rest until a force acts on it.
Acts on it.
Oh,
moves
right
it
here.
too, yeah.
And then the second part. An object in motion will stay in motion until a force acts on it. Very cool. That's Newton's first law. Newton's first law, I like it. And for Newton's first law, I wanted to show you guys what we have for you guys to experiment with Newton's first law. It's going to be our frog bowling.
That's right. Bowling with frogs. That's true. It's true. The frogs and the frogs. All right. Here we go. So this is the very cool frog bowling kit. Comes with everything you see here, including our little adjustable frog, so you can point and aim wherever you want to actually roll the little bowling ball. And it comes with, I think, even 11 pins in here, so you have an extra bowling pin in case you lose one. It even has 2 little tiny marbles that act as the little bowling balls. And it's really easy to set up. It comes with a little push bar on the side over here, so you leave it flat. You push the push bar, and it rises up this little yellow piece. And this allows you to quickly place the bowling pin so that it's ready to experiment with.
Oh, you don't have to like try to balance them or anything like that?
No, you don't have to try to balance them. The trick is find a safe spot on the floor. You have lots of space. Hold the button down. Add in the different pins. Let go. And you're ready to start bowling.
And I have one. I want to show them. I have one up here that I could get close up with the camera so you guys can see what it looks like. Oh, we just knocked him over. But if you actually press the button, you can see how it rises up. So when you take those pins, you can actually just drop them right in, and they're already going to fall right in. They don't even fall down because they have a little place to go. So you can see that right there. I taped the button down on this side over here. So you can see how that pins just sit in there. So that's a kind of a close-up of our frog bowling.
And the science about this frog bowling is, so how do we relate it to Newton's first law of motion? An object at rest. So you take the marble. You place the marble right here in front of the frog. It's at rest. It's what? At rest.
At rest.
And when you pull back the frog, it gets ready to use a force. In fact, we're using potential energy right here.
Ooh, from lesson
the
number
frog
1.
is storing that energy. And as soon as I release that energy, it puts a force, a push or a pull on the ball. The ball rolls and rolls and rolls until it hits those pins that were also at rest until the ball.
Oh, the pins were just sitting there, and they're going to stay sitting there forever.
Yep.
Until a force acts on them, and this force is the ball.
True, and even sometimes when I'm playing or my students are playing, sometimes they might bump it, and that would put a force on the pins, and they would also fall over. So be
like
ready
when I
for
tried
that.
to show the camera, and they all tipped over.
Yeah, that's what science is. Forces in action, right?
That's great.
Very good. So a really cool project. There's gutters to catch the little bowling ball, so a really fun project. Really cool.
Well, very cool.
Yeah.
Well, let's talk about Newton's second law, because we want to go over Newton's 3 laws of motion. And when we talk about Newton's second law, we talk about an object in motion already. And it's actually one of the coolest of Newton's laws because you can demonstrate it in so many different ways. Now, one of the cool ways to demonstrate this is with something with wheels. And you know what? I had one earlier. I wonder where I put it. That little truck. Oh, anyway, you can get something with wheels. You have a Hot Wheel or even, and I'm going to say it, even a chair with wheels on it. Maybe in the office or something like that, you might find a chair with wheels. And what I want you to do is try to find something with wheels. And we're going to do Newton's second law. You can even use, we had a can over here, a soup can that was actually perfect for demonstrating it too.
Yeah.
So Newton's second law is all about motion. So if we take something like an object, and I'm going to use this rocket right here. This is our stomp rocket. We're actually going to use it for Newton's third law as well, but I want to demonstrate with this rocket for Newton's second law. Newton's second law says the greater the force on an object, and I'm pointing to the object right now, the greater the force on an object, the greater the motion. Which means if I use a little bit of force, something's going to move just a little. But if I use a great amount of force, it's going to move a lot. And I can use this rocket just by itself. And I'll use a flick. We talked about a flick earlier. Let me move this out of the way. We said that with a little bit of force, it's going to go a short distance.
Yeah. Sounds about right.
Cool.
Yeah, looks right.
And with a greater force, oh, and it's gone.
And it's gone.
And the rocket launches. So you can see that the greater the force on an object, the greater the motion. And what a perfect way to demonstrate the greater the force on an object and greater the motion than playing a game of catch. Because everybody has had a chance to play catch at some point. And sometimes you'll get somebody and they'll say, okay, are you ready to catch it? And they're like, yeah, I'm ready. And then they'll throw it to you, only they don't throw it to you. They throw it way over your head and you have to turn around and run and grab it. That's because they use too much of that force. We want to use a little bit less, so there will be less motion. So we actually have something for you to use. We have our cat catch game. And you can show them our cat catch game, and I'll even help you out by walking off the screen for a second.
So this is our cat catcher. It looks like a cat, kind of cool. And it has two eyes. These eyes are actually bouncy balls, almost like super balls. They bounce really well. And they're soft foam, so you can't get hurt when you're playing catch. And you actually wear this almost like a baseball glove. So there's two sides. They have Velcro straps, which make it really easy. They're super adjustable for any size hand. So you adjust the straps so they fit. I think I adjusted this earlier. Maybe I didn't. Let's adjust these here. So your fingers go in one side. Your thumb goes in the other. The strap for your thumb is a lot smaller than the strap for your fingers. So that kind of helps you figure out how to hold it. And then you should be able to open this up. But I'm noticing this one, it can't open. And that's because there is a lock. The lock is kind of hard to find. Let's see if I can see it. Here we go. If I flip to this side, I see a little button right here, right above the nose of the cat. And if I flip this sideways, it will unlock and allow me to open. Let's make sure it unlocks. There we go. It opens the actual like little cat catcher.
Oh, very cool.
Once you've opened it, you can reach inside. You pull the little bouncy balls out. See, they bounce. Pretty cool. And what do we do with this? Well, this is like a glove, but it's also going to place a force on the ball, and it's going to launch it up into the air as well as catch it like a baseball glove. It's really cool. So if I wanted to like just drop it in here, I could show you how you catch it. You just, it's pretty simple. You basically just hold your hand open and then it catches it. And if I want to launch this up into the air, I open my hand, kind of pop it open, and it pops it up. Did you see that? Was pretty quick. Let's do it one more time. Ready? Here we go. 3, 2, 1. Whoa,
Oh, very cool.
And you can launch this, I mean, more than 60 feet into the air. It goes really, really high. Really cool. Do you want to step off?
I totally want to step
All
out there and throw one. Here, give me two of them.
Yeah, all right.
All right, here we go.
So you have to use the right amount of force.
All right, here
Right?
we go. First one.
All right, here we go.
First one. Here it comes.
Here we go. Whoa! Whoa, that was way too much force. Whoa, Newton's
I
second
think I
law.
have to use less of a force.
Yeah, less force. All right, here we go. Oh, yeah.
that was
Woo-hoo.
good.
All right, very cool. The cat catcher, one of my favorite projects. It's tons of fun. Lets you go outside, get some sunshine, launch this up in the air, and learn about Newton's second law of motion.
Very cool.
Wait, when I'm done playing with it, I don't want to lose the bouncy balls. So you open it up, you put them back in the little spots, you close it, and I lock it every time to make sure it doesn't
Oh,
open.
he's winking right now because I totally threw that ball way over there.
That ball, way too much force. It's gone. It's okay. We'll get it in a little bit.
Well, very cool.
Yeah.
Well, I want to talk about Newton's third law of motion because Newton's third law is a very exciting law. And I know we've been talking about a little foam rocket here, and this kit actually used to come with 2 foam rockets, but the second foam rocket is in a tree.
We might have had a little fun with the rocket on our own outside. We might have lost it in a tree, but we still have one.
So you should be careful when launching the Stomp rocket around the trees because it will end up in a tree.
They can get stuck.
Yeah, absolutely. But anyway, it's great for demonstrating Newton's third law. In fact, real rockets are excellent demonstrations for Newton's third law as well. And let me explain why. Newton's third law is all about action and reaction. You see, this rocket right here, if it was a real rocket, it would use fire and expanding gases to push the rocket into the air. And everybody knows that if you want to launch a rocket, first thing you do is shoot fiery hot gases this way so the rocket goes this way. Wait, does it shoot that fire?
I don't think that's right.
No.
That's right.
It shoots fire and hot gases this way, so the rocket will go this way?
Yeah, that's right.
Completely the opposite direction. And in fact, that's part of Newton's third law. Newton's third law says that for every action, there is an equal but opposite reaction. So I want you to think about a rocket when we're doing this. So we're going to say action, the fire and hot gases shooting down. For every action, there's an... Hey, what symbol is that?
It's an equal sign.
Equals. There is an equal but opposite reaction. And that's what launches our rocket. So we're going to do this one together. For every action, there's an equal but opposite reaction. And that's how our rockets fly. But it's not just how rockets fly. You ever watched a helicopter fly before? The blades spin around and push air this way, so the helicopter lifts this way.
Interesting.
Yeah, what about a boat, like a speedboat?
Yeah.
The propeller pushes water this way, so the boat goes really fast
Forward.
this way.
Oh,
For every
interesting.
action, there's an equal and opposite reaction. And that's really, really easy to demonstrate with a Stomp rocket. Because when I press down on this pad, it's going to force so much air through this tube and up this opening right here that it launches this rocket. But I'm not just going to launch it like as hard as I can. Number one, there's a ceiling. But number two, I can also use all three of Newton's laws for this rocket right here.
Whoa!
Let's start with the first one. Newton's first law says that an object at rest will stay at rest. So let's try that right now. We're just going to leave it sitting there. We're going to see if it moves by itself.
Here we go.
So it's just going to sit there the whole time. It's never going to go anywhere. Newton's second law says the greater the force on an object, the greater the motion. So if I press this a little bit, the rocket should launch a little.
Not bad. That was good force, actually. Not
Perfect
bad.
landing,
That was
too.
pretty powerful, yeah. Should we use a lot? Let's use a
But a
lot.
lot of force means it's going to fly really far. But first, let's talk about Newton's third law. For every action, I'm going to press down. There's going to be an equal but opposite reaction. And we're going to use a lot of force on this one. Here we go. Ready?
All right, here we go.
Oh!
man, that was a lot.
Hit the ceiling. Very cool. And that is our Newton's lab of motion. Very cool. Oh,
And now that we've learned about the Newton's third law, we're going to show you how to put this together really quickly.
yeah, that's great.
Because in the kit, it comes a little bit disassembled, but it's like 3 steps. So super simple. You guys ready for it? Here we go. I'm even going to disassemble it, show you how simple it really is. Here are your pieces. Are you ready? This comes assembled like this. You also have a black attachment. A little piece looks like this. You'll see one end is shorter, looks a little different. You take the white tube and you squish it
onto the short end.
onto the shorter end. You'll kind of have to twist and give it some push. If you need some help from your parents, ask them for a quick hand. All right, just like that. And then all we do, we take the stand with it pointing downward, curving down. We lower the stand down so it goes onto the tube, and we push it all the way through. And that's pretty much it. Yeah, super easy to put together. We made sure that the hose is in between 2 of these little red legs. You put the rocket on, and it's ready to launch.
Very cool. Well, we want to thank you guys for sticking around for lesson number 3. Come back for lesson number 4, and you guys have a wonderful day.
We'll see you at the next lesson.
The problem is,
It was a photo.
oh, it's still going.